Hey everybody, it's Mr. Carr again. Today we're going to be starting Unit 8 about trigonometry. So to do that, we're going to do a little bit of review of our right triangle trigonometry that you've done in the past, but then a little bit more on top of that. Okay, so let's start with some of our basics. When we talk about trigonometry, we're talking right now about sine, cosine, and tangent. You might have seen it this way where it's SOHCAHTOA. So sine, cosine, and tangent. Those are referring to the ratios in a right triangle of the opposite over hypotenuse. So we're talking about the opposite over hypotenuse. And let me mention that. Don't forget, theta here means an angle. Okay. So we're using theta to represent angles. It's kind of like a variable, but only for angles that we would use that for. Okay. So for example, when I say the sine of theta, we're referring to the ratio of the opposite over hypotenuse. Now, in addition to these three that you would have covered before, we're going to do three more. These are three more, which are called the reciprocals of sine, cosine, and tangent. So the reciprocal of sine is what's called secant. Okay. So when I say reciprocal, I mean secant is the same as 1 over sine. Okay. Secant, we just use three letters for that one. So SEC to represent that. Cosine, the reciprocal of that is going to be cosecant. Sorry, I got that wrong. Let me fix that. This is cosecant, and it's CSC for that one. My bad. Cosecant is the reciprocal of sine. Cosine, the reciprocal of that, is secant. I just had to mix up a little bit. So that is representing 1 over the cosine of something. So that is going to be represented as SEC. Tangent, the reciprocal of that is what's called cotangent. And again, that is 1 over the tangent. So we use COT to represent that. Okay. So when we do that, some kind of the way to think about it is if sine is opposite over hypotenuse, that means cosecant is hypotenuse over opposite. So all of these are flipping for that reciprocal. So this will be hypotenuse over adjacent, and this will be adjacent over opposite sides. Okay, so let's take a look at that as an example here. So we're going to find these 6 trig functions of theta. So first thing I need to do is I need to find the hypotenuse. So that'll be this h right here. Because we have a right triangle, we can do Pythagorean theorem. So I can do h squared plus 12 squared is equal to, sorry, geez, it's all mixed up. 5 squared plus 12 squared is equal to h squared. Now go through the normal solving process, but this is a Pythagorean triple. So that's going to be 5, 12. H is going to come out to 13 here. So now that I have that, I'm going to represent the sine of theta, the cosine of theta, the tangent of theta. I like to start with these first. So when I do that, one thing that might be helpful is to label your triangle with opposite, adjacent, and hypotenuse for their side lengths. So when I do my hypotenuse, it's always here. It's always across from the right angle. Then if I draw a line that crosses that right here, that is the opposite side of theta. And that leaves me one more, and that's adjacent. Adjacent, I also like to think of, it's attached. Adjacent, attached. Okay. So the sine of theta here is going to be opposite 12 divided by the hypotenuse 13. Cosine of theta is the adjacent side 5 divided by hypotenuse 13. And then tangent is going to be opposite 12 over adjacent 5. For my reciprocals, those are all going to be just the flipped version of my fractions. They're just reciprocals of the fractions. So if I want to do I did it again, cosecant of theta, that's just going to be 13 over 12. And then I can do the secant of theta, that's going to be 13 over 5. And the cotangent of theta is going to be 5 over 12. Okay, so that's our basic ideas of how we represent our different ratios and their reciprocals right now. Okay, so this one's got a little extra to it because if sine of theta is 3 over 4, find the 5 other trig functions. And we're going to leave our answers in simplified radical form when we do this. So I'm given that the sine of theta is 3/4. One thing we're missing here is we're going to need a third side. Remember, sine of theta equals 3/4 is a triangle. It's a triangle where the opposite side and the hypotenuse are 3 and 4. So I'm just going to draw a little triangle for myself. There. And there we go. So if this is theta, opposite is 3, hypotenuse is 4. I'm going to need to find this side. So I'll call it A for technically adjacent. But I can do my Pythagorean theorem. So a squared plus 3 squared is equal to 4 squared. So that's a squared plus 9 is equal to 16. Subtract 9 over. So that a squared is equal to 5. Or, geez, 7. And then I square root so that a is equal to the square root of 7. So I'm just going to leave it like that because we want to do simplified radical form. We already have sine, so let's do cosine. I'm just going to rewrite it again so for later. So that's 3 over 4. The cosine of theta is going to be adjacent root 7 divided by 4, my hypotenuse. And then tangent is opposite 3 divided by my adjacent root 7. Now, we don't like to have roots in our denominator. Okay, so no decimals and no roots in our denominator. So what we need to do is, or sorry, no decimals and no roots in the denominator. So I'm going to rationalize this by multiplying by root 7 and root 7. So that's 3 root 7 over 7. Okay, so that's these two I just solved. That's 2 of my extra 5. Now I need to do all my reciprocals. So I'm going to start with cosecant of theta. That's going to be just 4 over 3. Then I've got secant of theta. That's going to be 4 over root 7. But same thing, I need to rationalize this. So I multiply by root 7. So I get 4 root 7 over 7 for that one. And finally, cotangent. Now, I'm not going to take a reciprocal of this one because then I have to rationalize again. Let me go back to the original version. So that's going to be root 7 over 3. Okay, it's a little bit crowded. Let me spread this out just a tad here. There we go. Okay, so to solve any kind of triangles, we can look for missing sides and missing angles. We are going to be using our trigonometry buttons on our calculators for this. Okay, so we want to solve a triangle means we want to find the measures of all 3 sides and all 3 angles. Okay, so in this scenario, if we look at angle C here, for example, angle C is already given to us, it's 90 degrees. Angle A is given to us, it's 28 degrees. If we want to find angle B now, we're going to just take the complement of 90. So we know that all the angles inside add up to 180. So if I take 180 minus the 90 from here, that's going to give me 90. So these two angles have to add up to 90. So when I do that, I got 90 minus 28, and that gives me 62 degrees. So 90 minus 28 gives me 62 degrees here. For side lengths, we've given side B is going to be the one that's opposite that angle B. So that's given to us as 15. But now we need to find both A and C. So when we do this, we're going to do our trigonometry here. So the trigonometry of this case is, it doesn't really matter which one I do, but I'm going to stick with the 28 that I started with. If I look at this one, I label my sides. This is going to be the opposite side. This is going to be hypotenuse because it's across the 90. And then this makes that adjacent. So when I look at my options here, I know the adjacent. I'm going to look for the hypotenuse. I'm going to look for the opposite. I need to find both of those. So that means I'm going to do 2 trig ratios. So the first one I will do is, let's do tangent. The tangent of 28 is equal to the opposite, which is A, divided by the adjacent, which is 15. So from here, this is a button I'm going to put in my calculator. If I multiply both sides by 15, I get 15 times the tangent of 28 is equal to the side A. So 15 times tangent 28. Biggest thing here is make sure you're in degrees if you're doing it like this. So 15 times tangent 28 comes out to 7.976. Okay, so 7.976. Then for angle C, or sorry, for side C, that H, that's hypotenuse. Well, adjacent and hypotenuse is going to be cosine. If I take the cosine of 28, that's adjacent 15 over the hypotenuse C. Now in this scenario, if I call this over 1, I'm going to multiply both sides by C. So I have C times the cosine of 28 equals 15. And I can divide both sides by cosine 28. So C is equal to 15 divided by the cosine of 28. You can take some shortcuts with this steps if you want, as long as you keep track of everything. So that's why I plug in my calculator. So I get C is equal to 16.989 if I go 3 decimal places. Okay, so that's 16.989. So don't forget, some other strategies when solving our triangles, angles always add up to 180 degrees in a triangle. We can use Pythagorean theorem. I didn't do it this time, but let's say I gave you one angle or no angles, and I give you two sides, then you could do Pythagorean theorem to find the third side, and then you'll do a different thing for finding that part. Okay, and then just our trig. So, okay. One other idea we want to talk about today before we get to our last example, the angles of depression, angles of elevation. In a word problem, we talk about an angle of depression. You're talking about something up here and looking down at this angle. That's an angle of depression. So if I'm looking straight across, what angle do I make when I look down? Okay. The angle of elevation is if somebody's down here and has to look up at a certain angle to get to see some object up in the sky. Now, something to remember is the angle of depression for like this person here is the same as the angle of elevation for the boat up to the top of the cliff. Okay, so those two angles will always match up when we look at that diagram. So I look at this example here. We're flying a kite that has a string of 200 feet. You measure its angle of elevation to be 58 degrees. How high is the kite? Okay, so I'm going to set that up. First, draw a little picture. Okay, the kite has a string length of 200. Well, if you're standing right here, little stick figure here, here's your kite. Okay, so that's going to be 200 feet like that. That's what creates that hypotenuse is what it is. Its angle of elevation is 58 degrees. How high is the kite? I just want one specific number here, and that's going to be this length here. We'll call it X. Okay, and it's going in the upwards direction. Let's call it Y. So I need to set up my trig problem based on that. So just like we did before, let's label our sides. Sorry about that. So my hypotenuse is 200. Well, opposite the 58 there, and then this is adjacent. So which trig ratios use O and H? That's going to be sine. So the sine of 58 is equal to opposite divided by hypotenuse. So I multiply both sides by 200. So 200 times the sine of 58 is equal to y, and then I can plug that in my calculator. So 200 times the sine of 58. And I get 169 point, let's just go 61. It's going to be feet in this case for y. Okay. So then that's my final answer here. So again, everything here was just our regular trig, but the new thing is those reciprocal trig functions. So it's just taking your sine, cosine, tangent and flipping them over. But outside of that, we would use our sine, cosine, tangent buttons to find missing sides of our triangles that we can create. All right, that's it for today. Take care, everyone.